I want you to take a minute just to read this question. If you feel ready, you're more than welcome to give it a go, and then I'm going to go through it as well. If not, still read it. Try and give it a go. If you can, doesn't even matter if you don't get anywhere. Just see what happens. Even if you have to guess your way through, fine, so be it. But yeah, take a minute, read it, give it a shot, and then I'm gonna go through it. Okay, it's hard. Modeling questions with the integration and differentiation, in my opinion, I've always found them to be the hardest. Even with my students, whenever I give them a question to do, and I'm going through it with them afterwards, if they ended up going wrong somewhere, or if I'm just having to explain it, even I have a hard time, man. Like it's not easy. there's so many things going on. Um, practice. So let me go through this one. Let me talk you through my way of thinking, what parts of information I find, are useful, and then hopefully if you can get an idea as to how I think you might be able to implement that, doing your own questions. So you've read the question, part A. Let's jump straight into it. Show that t minutes after the tap is opened, dH by dt equals k cube root of h. Right. So dH by dt means the rate of change of h, which is your height. Okay. You've got the diameter of 20 meters here. That's going to come in handy. And we are using a cylinder, right? So we're going to make use of volume. How do you work out the volume of a cylinder? What's the equation? Pi r squared h. So if d is 20, that means r is 10, r squared is 100, so 100 pi h. Okay, now that we have v, we can work out dv by dh, which would be just 100 pi. Okay, the rate of change of volume is the cube root of the volume. I know that because it says water flows out of the bottom of the tank through a tap at a rate proportional to the cube root of the volume. So that means dv by dt, which is how I calculate the rate of that flow, is going to be minus the cube root of the volume. I put minus because it's always going outwards, right? The amount of water will never increase. It can only flow out. It can only go down. We're working with proportionality, which means we're going to have a constant. So C. Let me write this a bit clearer. There we go. Cool. We have the equation for V. So I can rewrite dV by dt as minus C cube root of 100 pi h. Okay, now let's use the chain rule. With the chain rule, dH by dt is going to be dV by dt times dH by dV. Yeah? Which is this equation flips upside down. dV by dt is minus C cube root of 100 pi h, and we're going to times by 1 over 100 pi. And now simplify. So minus C cube root of 100 pi h all over 100 pi. Okay, if you take out the h, you're left with minus c cube root of 100 pi all over 100 pi multiplied by the cube root of h. So I've just separated the h from that, okay? Which is going to be the same as minus k cube root h, where k is equal to everything inside this bracket. So the question says, show that t minutes after the tap is opened, dH by dt equals minus k cube root h for some constant k. There you go. This is my dH by dt. And that is part A done. Right. Next. Show that the general solution of this differential equation may be written as blah blah blah. We have a differential equation here. We have dH and then we have a h. Technically, there's no t term, but we do have a k. We're going to use that to our advantage. So, dH 1 over cube root of dH is equal to minus k of dt. So take the cube root h to the other side, take the dt to the other side, and now h minus a third is equal to minus k dt dh. Now ready to integrate. By integrating it, you would get 3 over 2 h to the power of 2 over 3 equals minus kt plus c. Because here we're integrating with respect to t. That's why it's just kt. If I had the integral of 2 in terms of dx, I would just get 2x. You stick that letter on there. Okay, now it's a matter of simplifying and getting it in the format that they wanted. Okay, so let's take the 3 over 2 to the other side. So h 2 over 3 is equal to minus 2 over 3 kt plus 2 over 3 c, which is the same as your minus qt plus p. Do you see? Where q is 2/3 of k and p is 2/3 of c. So h2 over 3 is equal to p minus qt all to the power of 3 over 2. Whoops, sorry, like that. There we go. So by taking the power to the other side, we just flip the power. If it's 2/3 on the left, it's going to be 3 over 2 on the right. Whew. I hope that wasn't too confusing. Hope that made sense. Okay, part C. Initially, the height of the water is 27. 10 minutes later, the height is 8. Okay, let's do that one. So find the values of the constant P and Q. We have the format for P and Q, correct? So now it's really just a matter of plugging in 0 and 27. So I'm going to do it just here. T equals 0, H equals 27. So 27 is equal to P to the power of 3 over 2. So P equals 9. Okay, it says 10 minutes later, the height is 8. So now T equals 10 and H equals 8. 8 equals 9 minus 10q to the power of 3 over 2. Yep. So now 4 equals 9 minus 10q. I did 8 to the power of 2 over 3. So q equals a half. There we go. That's that one done. Find the time in minutes when the water is at a depth of 1. Right. So we're going to take our new values for P and Q. So H equals 9 minus a half T all to the power of 3 over 2. And they said the depth is 1, which is H. Now we have to rearrange for T. By doing 1 to the power of 2 over 3, we still get 1. And rearranging that would give 16 minutes. Done. I hope that wasn't too bad. I hope at least some of that made sense. But as you can see, essentially what you're doing is making use of everything. There's still some chain rule involved. There's differential equations involved. They're going to bring in trig. They're going to bring in integration by parts and substitution, and quite literally everything you've done up until now, they're going to put it into a weird scenario like water flowing out of a cylinder, right? And they're going to get you to apply it. That's modeling. You've come across modeling enough to get an idea as to what it's going to be like. Yeah, that is modeling with integration.